Hi there, welcome to my channel. In this video, you will learn two things. First, to prove that two vectors are parallel. Second, to prove that the given points are collinear. To prove that two vectors are parallel, we must express one of the vectors as a scalar multiple of the other vector. For example, let's say you are given two vectors, vector AB and CD. Form equation relating these two vectors. For example, you can write vector AB equals to KCD or CD equals to HAB. Let's look at another example. Let's say you are given RS and vector PQ. Show that RS is parallel to PQ. Here RS is given as A plus B and PQ as 2A plus 2B. Form equation relating these two vectors. So I'm going to use PQ equals to lambda RS. You may use K instead of lambda. Substitute vector PQ as 2A plus 2B equals to lambda A plus B. Okay, you can factorize. Take out the common factor. Now you can compare in order to find the value of lambda. So here lambda equals to 2. Once you have lambda, then you can form the complete equation PQ equals to 2RS. And at the end, make sure you make the conclusion. Therefore, PQ is parallel to RS. Now, this is how you solve question asking you to show that two vectors are parallel. To prove that points P, Q and R are collinear. Now, if you are given 3 points P, Q and R, form vectors using these points. For example, you can form vector PQ, PR or QR. Choose two vectors to prove that they are parallel. So we just learn how to prove that the vectors are parallel. So you need to do all the steps to prove that the vectors are parallel. Now, for example, let's say I choose vector PQ and QR. So I need to prove that vector PQ is parallel to QR. And in additional, I need to state the common point, where for vector PQ and QR, Q is the common point. Or I may choose vector PR and PQ. So I need to prove that vector PR is parallel to PQ, then state the common point. So here P is the common point. Or I may choose vector PR and QR and do the same thing. Now let's look at another example. Let's say you are given 3 points, point A, B and C, where vector AB is 3A plus 3B and vector BC is A plus B. First, you need to form the equation. So vector AB equals to lambda BC. Substitute vector AB as 3A plus 3B equals to lambda A plus B. take out the common factor. Now in bracket you have the same vector, that is a plus b. Okay, compare to find lambda. Lambda equals to 3. Therefore the equation can be written as vector AB equals to 3bc. Now these are the steps you need to follow in order to prove that vector AB equals to vector AB is parallel to BC. Now at the end write the conclusion. Therefore point A, B and C are collinear with B as the common point. Let's look at another example. So diagram below shows a parallelogram ABCD. Point Q lies on the straight line AB and point S lies on the straight line DC. The straight line AS is extended to the point T such that AS equals to 2ST. And you are given extra information here. The ratio between AQ and QB is 3 to 1. Ratio between DS and SC is 3 to 1. Same. AQ given as 6A and AD equals to B. Okay, the first question, express in terms of A and B the vector AS and QC. And the second question, you are asked to show that the point Q, C and T are collinear. Okay, the first question, you are asked to find AS, vector AS. So in order to find AS, I'm going to follow the route from A to D and then from D to S. Okay, you can also follow the other route, that is from A to B, then from B to C and then C to S. Okay, so it is better for us to choose from A to D and then from D to S. Okay, using the triangle law. So AS equals to AD plus DS. AD, we have vector AD, that is vector B, but DS we haven't found yet. So from the given information, we have AQ, the ratio between AQ and QB equals to 3 to 1. Or it can be written in fraction form as AQ over QB equals to 3 over 1. Since AQ is given as 6A, therefore QB equals to 2A. And the ratio between DS and SC is given as 3 to 1. Therefore, now since it is a parallelogram, the magnitude of AB and DC, they are the same. Therefore, DS equals to 6A and SC equals to 2A. So now we have DS as 6A. So you can substitute into the equations. dA equals to vector B plus DS equals to 6A. Question A, Roman 2, find QC. So in order to find QC, you need to travel from Q to B and then from B to C. Therefore, the equation can be written as QB plus BC. Remember how to form the equation. The middle letter BB have to be same. So if you cancel out BB, you will get back the original vector, that is QC. Okay, you are given the ratio between AQ and QB as 3 to 1. So change this to fraction form. Therefore, you have AQ over QB as 3 to 3 over 1. AQ given as 6A. Therefore, QB equals to 2A. So, substitute this into the equation. So, QB equals to 2A plus BC. BC, vector BC equals to AD because this is a parallelogram. Therefore, BC equals to AD. Therefore, BC here equals to vector B. So, QC equals to 2A plus B. Show that the points Q, C and T are collinear. Using these 3 points, you can form 3 vectors. Vector QC, QT or CT. Okay, I'm going to use vector QT and QC. So the equation form will be QT equals to lambda QC. You have QC from the answer just now, that is QC equals to 2A plus B. So the problem now, we don't have QT. You need to find QT. So to start with, I'm going to use the equation AS equals to 2ST. Change this equation to fraction form to see the ratio between AS and ST. Therefore, the AS, the ratio is 2, ST is 1. Now, let's continue with QT. Vector QT. In order to get vector QT, you start from Q to A and then from A to T. So, QT equals to QA plus AT. QA is negative 6A, but you don't have AT. From the given ratio, find AT. AT over AS equals to 3 to 3 over 2, or AT equals to 3 over 2 AS. Use this, substitute this into the equation. So you have QA plus 3 over 2 AS. Now, how about AS? You have AS from the answer A Roman 1. AS equals to 6A plus B. So substitute, simplify. Okay, QT now equals to 3A plus 3 over 2B. Now we haven't found the lambda. So in order to find lambda, you need to take out the common factor 3 over 2. So that in bracket you have 2A plus B, which is equals to QC. So QT equals to 3 over 2 QC. Now, these are the steps you need to do in order to prove that QT is parallel to QC. And at the end, you write the conclusion saying that points Q, C and T are collinear with Q as the common point. Thanks for watching. For more videos, please do subscribe.